You're watching the Weiss channel. Today we continue talking about probability, where we basically have to make a chart. So it's considered a compound probability where you have and or. So the most important words here are going to be and or, okay? We're gonna have and or, okay? So in this first one, it says in a class of 29 students, 17 play basketball and 6 play baseball. There are 8 students who play neither. What is the probability that a randomly chosen student plays both baseball and basketball? So here's what you got to do. You have to make yourself a chart, all right? Now in black here are the given numbers, right? So look, you've got people that play basketball, don't play basketball. Then you have play baseball and don't play baseball. And then there's a total, okay? You have to set your chart up like this. So you're given that a total of 6 play baseball, okay? You're given that a total of 17 play basketball. And you're also given a total of 8 don't play either. So that doesn't play baseball and doesn't play basketball. And you're told that altogether there's 29 people in the class. So in order to, you have to fill in the rest of the numbers. So for example, if this is 17, right, and this is 29, you got to put 12 here because 17 plus 12 is 29. If this is 6, then this is going to be 23 because 6 plus 23 is 29. Okay, so now what you're going to do is you're going to say, okay, if this is 23, right, 23 minus 8 is 15. Okay, and then 17 minus 15 is 2, and then 2 plus 4 makes 6. So you just fill in all the numbers. So then the question was, how many play both baseball and basketball? And that's right here. Play basketball, play baseball. 2 out of 29, and there's your answer. There's a spinner with 15 equal areas numbered 1 through 15. The spinner is spun one time. What is the probability that the result is a multiple of 3 or a multiple of 4? Well, what are the multiples of 3 here? Well, there's 3, 6, 9, 12, 15. And I put a square around them in green. What are the multiples of 4?
Good morning, Vice Principals.
8,
Your
12.
breakfast is available and ready in the guidance department. Please come down to see us. Thank you.
So 4, 8, and 12 are all multiples of 4. And those are circled in purple there. Now, how many are there altogether? In other words, 6, for example, that is a multiple of 3. It's not a multiple of 4, but it's one or the other. All right. 8 is a multiple of 4, but it's not a multiple of 3, but it's one or the other. So how many are there that are either multiples of 3 or multiples of 4? 1, 2, 3, 4, 5, 6, 7. Okay, so there are 5 multiples of 3, there are 3 multiples of 4, but this 12 is a multiple of 3 and 4, so we can't count it twice. I gotta remove that, I gotta remove one of those. And you get 7 out of 15. In this one, it says, what's the probability that you have a multiple of 3 and a multiple of 2? All right, so the multiples of 3, okay, are circled in green. Here's 3, 6, 9, 12, 15. The multiples of 2 are circled in red. 1, 2, 3, 4, 5, 6, 7. Okay. Now, where are they both circled in red and green? Well, you got 1, 2. Okay, because they have to be both. Can't just be one or the other. That's the difference between and or. All right? And means it has to be both. Or means it can be one or the other. So how many is it? It's 2 out of 15. Okay. Over here, in 23 students, 7 play basketball, 12 play baseball. There are 9 who play neither. What's the probability that a student chosen randomly plays basketball or baseball, one or the other? Okay. Well, once again, you're given these numbers. The black ones you're given, okay? 12 play baseball, okay? 7 play basketball, okay? 9 play neither, okay? And 23 students altogether, all right? So what's the probability that a student plays either basketball or baseball? Here's the best way to do that. Just take the 23 total students and subtract the number that play neither. 23 minus 9 is 14. So your answer is going to be 14 out of 23. You've been watching the Weiss channel.